Now, third topic of this chapter is nothing but to determine the resistance of a galvanometer by using meter gauge by Kelvin method. That's why this is called the Kelvin method to determine the resistance of a galvanometer. Now, this expression is also divided into three parts: construction, circuit diagram, and working. Now, we have to discuss about the circuit diagram. So, this circuit diagram of Kelvin method to determine the resistance of a galvanometer consists of three copper strips C1, C2 and C3 consist of two gaps, left gap and right gap, fixed on the rectangular wooden board between the 2 points A and C as shown in the diagram. Between this point A and C, there will be the wire of 1 meter length of uniform cross-sectional area is connected. Below the wire, there will be meter scale is to be attached. Now the EMF of a cell plug K and rheostat IH is connected between the point A and C, which is as shown in the diagram. The known galvanometer in which its resistance is calculated is connected in the left gap, and the known resistance box is connected in the right gap of the meter bridge as shown in the diagram. So this galvanometer G is connected in the left gap whose resistance is to be calculated. Say that resistance is G, we can find the value of G by using this network by Kelvin method, which is connected in the left gap. The known resistance box is connected in the right gap of the meter bridge, and the whole setup will be fixed on the rectangular wooden board. This is called as the Kelvin method to determine the resistance of the galvanometer. Now, the jockey is connected at the central point B to the copper strip C2. Jockey is connected like this. So this is the construction of Kelvin. Now this whole expression can be divided into three parts: construction, diagram, and working. Now construction, once again, this Kelvin method is used to determine the resistance of a galvanometer by using meter gauge. It consists of three copper strips C1, C2, and C3. Is connected, is fixed on the rectangular wooden board, consisting of two gap, left gap and right gap between the 2 point A and C. A wire of uniform cross-sectional area of length 1 meter is connected between A and C. There will be EMF of a cell, plug K and rheostat RH is connected across the point A and C. In a left gap, there will be the galvanometer is connected with resistance is to be determined, and the known resistance box is connected in the right gap, and the jockey is connected at the central point of the copper strip C2 as shown in the diagram. Now this is the circuit diagram. Now we have to discuss about the working. So the first point of the working is nothing but remove the certain resistance from the resistance box. Remove the certain resistance from the resistance box. Galvanometer shows a certain deflection. Now, adjust the rheostat such that touch the jockey on the different point. Galvanometer shows certain same deflection at 2/3 of the wire. Means, first point of the working is remove the resistance from the resistance box, close the plug K, current flowing through the wire, and galvanometer shows the certain deflection. That is the first point of the working. Once again, remove the resistance from the resistance box and close the plug K. Current is flowing through the circuit, and galvanometer shows certain deflection by adjusting the rheostat. Now the second point. Now touch the jockey on the different point of the wire. Galvanometer show different deflection, but at a particular point D. Again, galvanometer shows same type of deflection as that of before. Fix that point D. Means wire can be divided into two parts, AD and BC. Means that point D can be divided the network into two parts. Means our network which is in balancing condition. Measure the left length of the wire, that is called LG, and right length of the wire, that is called as LR, by using the meter scale which is attached to below that wire. This is the second point of the working. Once again, the first point of the working is remove the certain resistance from the resistance box, close the plug K, now the current flowing through the wire, and galvanometer shows a certain type of deflection by adjusting the reverse time. Second point, touch the jockey on the different point on the wire. Galvanometer show different deflection, but at a particular point D, galvanometer show the same type of deflection. Means our wire can be divided into two parts, AD and DC. Means our network should be in a balancing point, balancing condition by bending the point D. Means the potential at point B and potential at point D have the same. Means these are the two equipotential point is produced. Means our network which is in balancing condition. So these are the two working point to describe this network. First point and second point. Second point once again. Touch the jockey on the different point. We get the point D. Means our galvanometer show the same type of deflection as that of before. Fix that point D. Means B and T, these are the equipotential points, means our network which is in balancing condition. So this is the second point. Now, the galvanometer resistance is G. G with the resistance of the galvanometer is directly proportional to the left length of the wire, which is nothing but G is equals to rho Lg by A, where rho is the resistivity of the wire or the specific resistance and A is the area of cross section of the wire. Similarly, the known resistance R is directly proportional to the right length of the wire. Means R is equals to rho Lr by A. This is equation number 1. This is equation number 2. Means the left length of the wire, which is directly proportional to the resistance of the galvanometer, or the resistance of this resistance box is directly proportional to the right length of the wire. We have already discussed in area 1. So from equation 1 and 2 we can divide this two equation. Then G by R is equals to rho Lg by A upon rho Lr by A. Rho A cancel. So G by R is equals to Lg by Lr. Means G is equals to Lg by Lr into capital R. This is the relation of Kelvin method to find the resistance of the galvanometer. By knowing the value of Lg and Lr by using meter scale which is attached to the below that wire, we know Lg and Lr. And this is a known resistance box which value is already known. So we can find the value. Means this network is to find the value of resistance of a galvanometer by using this is also we can be deduced. G is equals to Lg upon 100 minus Lg. Means this wire should be 100 centimeter. Means 1 meter. So this value is Lg. So this is 100 minus Lg. We have already, it is replaced by Lr. But it is also called as 100 minus Lg. This expression can be expressed like that. Means this is a expression for finding the value of unknown resistance of a galvanometer by the Kelvin method.